Welcome back. In this video, we are going to cover the mathematical representation of the so-called park transformation method. Remember that this operation is needed to change from the XY stationary coordinate system to the DQ rotating reference frame. For this operation, we shall utilize the angle information of the PMSM rotor measured by either an incremental or a sine-cosine encoder to perform this transformation. This is the most crucial part of the FOC algorithm in terms of synthesizing the appropriate direct and quadrature current components for the current controllers that we are going to cover in details as well. Remember that the inputs of the part transformation are the X and Y current components that are interpreted in the stationary reference frame, which means that they are AC-like quantities. At least we can say that for the sake of simplicity. The output of the part transformation are the D and Q current components that are interpreted in the rotating reference frame, which means that they are DC-like quantities tied to the PMSM rotor. Let's discuss how the mathematical representation of the park transformation actually looks like. In the picture, you can see the interpretation of the XY and DQ coordinate systems. It is worth to mention that the XY plane's orientation is the same, while the DQ's frame orientation is changing because the direct direction is tied to the rotor's pole flux, which means that it is rotating with the rotor of the PMSM motor. The correlation between the two coordinate systems is the theta angle, which is interpreted between the D and X axis. Our goal is the same as before. We would like to describe the resulting stator current vector in different coordinate systems. This time, we shall find the mathematical connection between the stationary XY and rotating DQ frames. You can see the matrix equation of the park transformation on this slide. As you can obtain, the scalar equations can be deducted from the matrix representation by utilizing the row-column multiplication method. The basic idea behind the park transformation is to express the relevant direct and quadrature components with respect to the relative position of the d-axis to the x-axis, considering the input x and y current components. The product of the relevant trigonometric functions and measured phase currents are pointing to the appropriate direct or quadrature direction based on which scalar equation we are looking at. So, all in all, the park transformation is responsible to represent the measured phase currents in the rotating reference frame that is tied to the rotors of the PMSM motor. The matrix equation can be easily interpreted as scalar equations as well regarding these two directions. The latter equations can be implemented with ease in MATLAB Simulink or any other programming language. An important criteria is the precise measurement of the rotor pole flux position, which is resulting in an increased sampling frequency for the field-oriented control compared to the previously mentioned block commutation method.